Hey everyone, so this is Monil Shah, and in this subject MSDS 460 I'm representing group 1. In our group other than me we have Supriya, Abhigna and Vivek. Okay, I am now presenting a project which is optimizing investment portfolios by transitioning from mutual funds to index funds. Starting with the motivation, we see a lot of retail investors investing in the mutual funds, and in this process they also have to pay some hefty amount of expense ratio, which is about 1.5 to 2.5% of their total AUM. To put this in context, let's say a user has invested in some mutual funds through SIP throughout his life or for many years and accumulated a wealth of 1 crore rupees. Every year he would have to pay about 2 lakh rupees or 2.5 lakh rupees as management fees to these mutual funds. That's quite some money. In comparison, index funds only charge fractional amount of money. So what we are proposing is we can optimize or we can recreate or mimic their mutual fund portfolio through the index funds such that their original portfolio in terms of stocks remains almost same, or we try to maximize this overlap between these two. So to visualize this, let's say a user invests in 3 different mutual funds, which is MF1, MF2 and MF3, and for simplicity we say he invests 100 rupees in each of them. Now we have a mutual fund 1 which invests 10% in stock 1, 40% in stock 2 and 50% in stock 3. Same way holdings of mutual fund 2 is given here, same way holdings of mutual fund 3 is given here. We can look at the whole diagram and we can say that any amount that user puts in mutual fund 1, 10% of it goes to stock 1. Any amount that user puts in mutual fund 2, 20% of that goes to stock 1, right? So let's say if we fix the amount, then we can say that out of this 100 rupees, 10 rupees goes to stock 1, and out of this 100 rupees, 20 rupees goes to stock 1. In summary, stock 1 gets total of 30 rupees out of 300 that user has totally invested in mutual funds. The stock 1 in essence takes 10% of the user investment amount. Similarly, stock 2 gets 20% of the total amount, stock 3 gets 40% of the total amount, and so on. So here we term this thing as a melting of the portfolio, and why we call it melting is basically we melt the outer layer of the mutual funds and we keep it at the stock level, right? So we started from the mutual fund proportions, how much user invests in different mutual funds, and we'll end up with how much user invests in different stocks and the percentage of that, right? Okay. On the other hand, we have, let's say, a shelf of index funds, and we call them ID1, ID2, ID3. And we are going to play with their weights such that the stock 1 percentage that will come out in the index fund portfolio will match to the stock 1 percentage in the melted portfolio, which is 10% in this case, right? At the same time, we also want to match the stock 2 percentage in the index fund portfolio with the stock 2 percentage in the melted portfolio, and so on. So if there are 2,000 different stocks, we have to make the 2,000 different constraints to match the weights, right, in both the portfolios. In terms of, let's say, for example, we keep this as a variable. So if we say the ID1 is the weight of total fund that we invest in index fund 1, and ID2 is a weight of total fund that we invest in index fund 2, and so on. In that case, we can say that stock 1 gets 30% of whatever we put in index fund 1 and 20% of whatever we put in index fund 2. So stock 1 can be written as 30% ID1 and 20% ID2, and so on. And this we have to equate with 10% because in the melted portfolio we have 10% of stock 1. Okay, so such that we can make constraints which 1 per each stock. Okay, and then our goal is to balance both the side in terms of stock level, and that is what we call as overlap. Okay, now coming to other measures, we have the expected return and HHI. Expected return, we take the 10-year CAGR as a proxy. Wherever the data is not available for 10 years, for example, some stocks recently got listed. In that case, we take whatever history is available, whatever longest CAGR we can get. Our fundile index is basically an index of a concentration. Higher the number, higher the concentration. So its calculation is very simple. Let's say you want to calculate at different asset level. You can say asset A is 40% of the portfolio, asset B is 30% of the portfolio, and so on. You just have to square their weights. So 40 square, 30 square, 20 square, and 10 square, you get 3,000. If instead of asset you have the sectors, say financial is 40% of the portfolio, telecom is 30% of the portfolio, and so on, that becomes a sector level HHI, and we essentially take that in the account. Okay, in general interpretation, anything less than 1500 is well diversified portfolio. 1500 to 2500 is basically moderate level of concentration, and above 2500 is high concentration. This is a general benchmark. Okay. Okay, coming to literature review, we have done the literature review of a couple of papers where, for example, this paper is trying to enhance the index fund tracking, and they have the certain objectives, right? Multiple objectives such as maximizing return, minimizing the tracking error of your portfolio with the index, and so on. So this becomes an exercise of the goal programming. We also saw a couple of papers which are addressing weighted goal programming and fuzzy goal programming in case we want to keep the weights a variable. We also saw a couple of papers which also address this mimicking problem through heuristics and evolutionary algorithms. So we took part of that also in our project. Let me come directly to what we did and what we picked from these papers. So we initially don't take all the constraints as a part of the optimization. So we just took two of the constraints, which is expected return constraint, which we just saw here, and the overlap constraint. So all, let's say, 2000 different stocks and one constraint for each of them. So that would be a long list of constraints. We run them because both expected return constraint and the overlap constraints are linear constraints. This can be run through goal programming, and we get some initial solution. This initial solution is in terms of how much we should invest in which index funds. So for example, ID1 10%, ID2 50%, and so on. Something like that. In that framework, we get some initial solution. Now we find some neighborhood solution that we do by changing some weights of index fund 1 and adding that weight in some other index fund randomly. We find some neighborhood solution and try to calculate the expected return overlap again, and we also calculate this time HHI at the sector level. And we have defined some criteria to call it as positive improvement or not. So if through the neighborhood solution we get some positive improvement, then we keep that solution and reiterate around the neighborhood of that solution. And we keep iterating it for multiple iterations, let's say 1000, and whatever final solution that we get, we keep that. Now you see some boxes are in the orange color, which are basically possible constraint that we can add in the heuristics in the future iterations. For now, for this project, we haven't added that. So for this project, we only have expected return, overlap, and sectoral HHI constraint. But in future, let's say you can add a constraint on VAR. You might have some preference over some fund houses. You might have some constraint on stocks or sectors or a geography the stocks is operating on, and so on. So all these constraints we can put it as a part of heuristics. And one of the reasons why we kept this two-way approach, where we first take the initial solution through goal programming and then run the heuristic on that, is because all these non-linear or maybe non-convex constraints can be addressed through the heuristics, right? Now this is should be the same as what we discussed just now, but this is in terms of how we address in the code. So all the gray boxes are data. So we have the user portfolio, which we take through Excel. Then we have mutual fund holding data, which we scrapped from Money Control. Index fund holding data, which we scrapped from screener.in. And now we feed it to, for example, make a melted portfolio, calculate user expected return, calculate user's current HHI in his current portfolio. And we feed them in the goal programming. Similarly, on the other hand, we also feed the stock-wise weights, which is basically this slide as we discussed, right? So this also becomes a right-hand side of left-hand side of constraints, and so on, right? So we calculate the stock-wise stock weight as a function of index fund weights, and expected return as a function of index fund weights, and all this calculation happens on the right-hand side and also fed in the goal programming. We calculate initial solution. First, we assign the final solution as the initial solution and try to see if the neighborhood solution is better or not. If it is better, then we update the final solution, and so such like this, we iterate over the loop and find the final solution after some pre-specified number of iterations, right? Now let's go to the results. So here we basically have a user existing return 16% and target HHI is 343, and we directly go to the results that we get after some improvement and so on, and we see that this is the recommendation that we give you, that user should invest in ID 11 this much percentage, ID 12 this much percentage, and so on. And by doing so, user will get 2.32% alpha. He can keep 61.8% of the portfolio as same, and HHI also remains around the same range, right? We did some this calculation for, let's say, 50 different users by creating some random portfolios of 50 users, and we get on an average 61%, 61.4% overlap. So we can say that about 60% or more than 60% portfolio remains same as what they have currently, even though we switch from the active fund to the passive fund. We get about 2.5% more return, and that too basis of the 10-year CAGR. And the sectoral HHI we don't disturb, so it's about 340. It's about the same range. So we don't get concentrated on any particular sector, even though we get some higher returns, like a significant higher return. And then overlap is also not minuscule. There's significant overlap with the existing portfolio. So yeah, our recommendation basically through this project is we can optimize the existing portfolio through many constraints that user might have, and still get to invest in the index fund, which basically omits the fund manager risk. That you don't have to pay and manage hefty management fees. You can get higher alpha. You don't have to be concentrated in any particular sector and so on. So it's improvement in overall cases. It's the overall case of improvement, and we would recommend user to do this. Thank you.